Hello students, I welcome you all for our test series. See, as I would have told you earlier in my video that we have planned 3 such tests. Okay, 25 questions. Of course, I will stipulate the time which you should take in attempting these questions should be not more than 75 minutes. Okay, because you can't spare more than 75 minutes during your examination. I mean, that's the standard thing which we consider. Now, see, the purpose is I have prepared 3 different type of level of paper here: easy, moderate, and a bit tough. Okay, keeping in mind the pattern which we have observed, we have analyzed in the last few years, that the initial shifts are easier than following them, then slowly and gradually move on to the difficult one. Okay, so keeping that in mind, we have planned 3 such tests. So it's the beginning. So the first test paper is here. I believe you all would have attempted it. Now let's move ahead with the solution part. See, answer I will show you so that you can match, but I may not be getting to the final answer because then it will take long time. Okay, neither you have that much time and not I want to spend my time in the calculation part if it gets very difficult or lengthy. Okay, so let's start. Find domain of C. That's the first paper. Okay, let me tell you all that I considered this paper to be the easier one for the for moderate one, not easier one, moderate one, bachcho. Okay, you will find few very good questions because I myself prepared, I mean selected the question. I won't say that I have written the questions here. Maybe 3-4 questions I have framed from on my own, but rest of the question I have selected from books. But I will keep this paper as a moderate or on the higher side of it, or on a bit difficult side of the paper. Okay, as far as JEE mains is concerned. So the domain, see, that's an easy question, isn't that? So for domain, we know anything within square root has to be greater than equal to 0, but at the same time denominator can't be 0. So it's sin x greater than equal to 1 by root 2. I think all of you will agree. And in the denominator, if I take LCM, so it's minus 2x squared plus 3x minus 1 should be greater than 0. Now we have to solve this. Of course, the first one we will solve to start with, because that's a simple quadratic, open down. So I will just multiply both the sides by negative. So it's 2x squared minus 3x minus 1, and that is plus 1 is less than 0. Okay, so using middle term split we can factorize it, and what do we get here? So the factors are 2x common, it's x minus 1 minus 1. So 2x minus 1 into x minus 1 is less than 0. Now open upward quadratic, bachcho. And open upward quadratic is negative between the roots, yes or no? Okay, so see, these are few small points which may help you in solving these such type of inequality quickly. So for those who know it, it's really good. For those who might have missed it, so now they shouldn't forget it. So open upward quadratic, so that's why I multiplied both the sides by negative 1, so as to ensure that the leading coefficient is positive. Okay, so less than 0, so that means between the roots, so between half and 1. So that's one solution. Now the next one is sin x has to be greater than equal to 1 by root 2. Okay, now see, sin x is a periodic function, we all know it, isn't that? So that's it. So it has to be greater than 1 by root 2. So how do I approach it? I approach it using the curve here. So I will draw the line y is equal to 1 by root 2, and we need sin x to be greater than or equal to it. So which portion is greater than or equal? So that's the portion of the sine curve which is above the line, or of course equal to it. So when is sin x equal to 1 by root 2? In first quadrant sine is positive, and in second quadrant sine is positive. So in first quadrant we all know it's pi by 4. Now again, recall this, what do I say, the angle with respect to the quadrant. So if we know the angle in the first quadrant as theta, then corresponding angle in second quadrant is pi minus theta, in third quadrant is pi plus theta, and fourth quadrant is 2 pi minus theta. And if we wish to go like clockwise here in green, okay, so in that case the fourth quadrant angle will be minus theta, and third quadrant angle will be minus pi plus theta. Don't forget this. Okay, now since sine is positive in first quadrant and in second quadrant, first quadrant angle is pi by 4, hence the second quadrant angle is nothing but pi minus pi by 4. So that means theta or x belongs to pi by 4, close pi by 4 to 3 pi by 4 बच्चों. Now we have to take its intersection with the interval half to 1 here, isn't that? So now of course 3 pi by 4 is greater than 1, so the answer should be closed pi by 4 till rather pi by 4 is half to pi by 4, I am sorry, half to pi by 4. Let's check here, and what is it? So options are half to pi by 4, isn't that? That means I got it wrong. Pi by 4 is how much? Okay, I'm sorry, 3.14. Okay, so not that one. So okay, I was writing it correct in the to start with. Okay, so pi by 4 to 1, closed pi by 4 to 1, that you can do. Okay, that's just to find the intersection, that you can very easily do it. That's it, right? That's it. Okay, so that's an option, pi by 4 to 1. So C1 should be the correct one. Okay, so this is how you can approach any inequality involving trigonometric function with the help of curve. Now moving to the second question, if f is a polynomial such that f of 1 minus x upon this, now look at this one and this one, how are they related? So if I say 1 minus x upon 1 plus x is t, then 1 plus x and 1 minus x is of course 1 by t. Relation is f of t into f of 1 by t is equal to f of t plus f of 1 by t. Now function f of t is a polynomial function. Okay, and few more informations are there, like f of 3 is 28, and then once we know that function we can solve it. Okay, because we just need the values f of 1, f of 2, f of 3 until f of 10. So once we know what is f of t or f of x, we can just put the values, those values for x, and then add them up. Okay, so that's not a big big requirement, but that's the thing which will tell us what function or which type of polynomial it can be. So how did I solve it? See, when I tried to solve this question, so I started with like a times t raised power n, b times t raised power n minus 1, c times t raised power n minus 2 till how many terms will be there? There will be n plus 1 terms. If I start with my general polynomial, isn't that? So n degree polynomial, so it's n times t plus p, let's say. So therefore f of 1 by t will be of course a by t raised power n plus b by t raised power n minus 1 plus c by t raised power n minus 2 and so on n by t plus p. Now just multiply and add them, bachon. So what do we get? We get a times t raised power n plus b times t raised power n minus 1, c times t raised power n minus 2 and so on. This is like nt plus p into a by t raised power n minus n, b by t raised power n minus 1 plus c by t raised power n minus 2 and so on, like m by t square plus n by t plus p, and this is equal to c. That's a relation which is true for every x except for x is equal to plus minus 1 here. Okay, so that means it's an identity statement, and this is like a times t raised power n, b times t raised power n minus 1 and so on nt plus p, and f of 1 by t will be a by t raised power n plus b by t raised power n minus 1, c by t raised power n minus 2 plus n by t plus p. Okay, now what will we do here? Of course, the simplest thing which I can think here is to compare the coefficient. So if I compare the coefficient of t raised power n, both the side. So how will you get it? You get it only in one case, when you multiply this by t. So this is ap, this is equal to a. Now a can't be 0. Why? Because if a gets 0, that won't be a polynomial. Why? Because see, I assume the general polynomial with degree n, and a is its leading coefficient. So if a gets 0, and then the leading coefficient will be b, that has to be 0. So leading coefficient can't be 0 if I have assumed it to be of degree n. I think you are clear, because see, if I remove this, then that's the polynomial whose leading coefficient is b, and this statement will always tell you that one of the option is leading coefficient is 0. So I will say that leading coefficient can't be 0, so that gives me the value of p here. That gives me the value of p here. Now let me just collect the coefficient of t raised to the power n minus 1. Okay, now what's the coefficient of t raised to the power n minus 1 here? How will we get it? We will get it as when you multiply this by this, so this is an. Is there any way of any other way? Right, t raised to power n minus 1, when you multiply it by this, so this is bp. I don't think we have any other way of getting it, isn't that? Okay, t raised to power n minus 1 multiplied by this and multiplied by this, right? Right, now here t raised to power n minus 1 is nothing but b here. Okay, now what? See, so since p is 1, okay, I think we got it. Since p is 1, so that gets cancelled, an is 0, so that tells us that n is 0 because a can't be 0. So similarly, we can say if we go for coefficient of t raised to the power n minus 2, so what will that be? So t raised to the power n minus 2 will be a m plus b n and plus c p, and here it will be, I think, c, right? It will be c. So again, since p is 1, so c and c gets cancelled, and n is 0, so you got a m is 0, so that means m is 0. Now following that pattern, we will conclude, see, a is 1, okay, a is 1 and p is also 1. Now you may say that how are we claiming that a is 1? So for that sake, I will see, that is one for sure that n, m, c, b, they will all get 0 one by one, they all will get 0. Now what remains is, if I collect the constant term here, if I collect the constant term here, so it's 2p in RHS, in LHS it's a square plus b square plus c square and dot 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 n square, since they are all 0, plus p square. P is 1, so 1 is equal to a square. Okay, so a can be plus minus 1 here. A can be plus minus 1 here. Okay, and for that sake, let me yeah, I think a can take two values. Okay, so now let's go for, so therefore the function is, it can be like a, so x raised to the power n plus minus plus 1. So that's what I concluded here. Okay, now since we are given that f of 3 is, how much is it? F of 3 is 28, right? So we are given that f of 3 is 28. If I put the value here, bachon, so what will we get? Plus minus 3 raised to the power n plus 1 is equal to 28. So 3 raised to the power n is 27 plus or minus. We are not left with choice. So of course we can say that a is 1 and n is 3. Hence, see, we got the function. So therefore our function is x raised to the power 3 plus 1. That's it. That's it. So plus 1 minus 1 gets cancelled. So ultimately it's nothing but summation r cube when r goes from 1 to 10 and 1 upon 605. And now you can simplify it to get the answer, bachon. Okay, so that's it. So that was second question. I believe you all would have got it, and that's the answer here, the A option. Now moving to the third one. Third question is, if 1 omega, omega square, omega raised to power n minus 1 are the nth roots of unity, then the value of this expression is, see, this one is based on the simple direct two things, two statements. First one, which we shouldn't miss at any point of time, and that is the nth roots of unity. What are actually they? They are actually the roots of this equation z raised to power n is equal to 1. So nth roots of unity are the roots of this algebraic equation. Okay, now we know, once we, and that's see, I said two very basic statements. So this we need to know, either we already know, because what we know is, if we are given roots of an equation, we can write that polynomial in terms of the factor. So I can write it as z minus 1 into z minus omega into z minus omega square and dot 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 z minus omega raised to power n minus 1. That's it. Now if you compare it with the given question there, so we can very easily see that if I replace z by 2 here, we get the answer, isn't that? So 2 raised to the power n minus 1 is 2 minus 1 into 2 minus omega, 2 minus omega square into 2 minus omega raised to power n minus 1. So that's what we need. Okay, so the answer is simply 2 raised to power n minus 1. Okay, so that's the only option here. Rather, that's one again an option. But then, see, from binomial expansion we already know. So let me write that one also. We know that summation NCR, R goes from 0 to n, is nothing but 2 raised power n. So what do we have in LHS? We have sum of all binomial coefficient starting from naught NC0 till NCn, and that's 2 raised power n, but NC naught is 1. So 2 raised power n minus 1 is nothing but NC1 plus NC2 until NCn bachcho. Okay, so any one of these two is the correct one. So that's why they have written this comma that bachcho. Okay, so that was our third question. Now moving to the fourth one, answer is there. Fourth one is total number of ways in which 7 green caps and 8 blue caps can be arranged in a row. 7 green and 8 blue. Okay, exactly one pair of green cap is side by side, assuming all caps to be identical. I mean same color caps are identical. Okay, so see how I tried this question. I said, okay, in how many ways I can put 8 blue caps? 1, 2, 3, 4, 5, 6, 7, 8. Since all blue caps are identical, we can put them in only one way. We can arrange them in a row only in one way. But then I will count the number of gaps we have. 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 1 gap. We have 9 gaps. Okay. So out of these 9 gaps, select any one gap and put 2 green caps there. Again, since all green caps are identical, so you just select any gap and put those 2 green caps there. How many caps are we left with? We are left with here how many caps? 7 caps. Okay, we are left with here 5 caps. 5 caps, and then how many gaps are left? We are left with 8 gaps, but 7 caps are identical. Okay, and we are left with 8 gaps. So what shall we do here is, wait, see, 8 gaps means 8 boxes. 3, 4, 5, 6, 7, 8. We are left with 8 boxes, and how many caps we are left with? We are left with just only 5 caps, and we know that in no slot we can put more than 1 cap. Okay, so that's simple. So the simple distribution is this. That's it. 5 gaps, 1 cap, and then 3 gaps, 0 caps. So in how many ways we can do it? 8 factorial by 5 factorial into 3 factorial. That's it. That means you have to just divide your caps in 5 caps in 8 groups, such that 5 has 1, 1, 1 and 3 has 0, and then distribute that group among these person. Okay, so we have to just simple, or it's really simple. Okay, for the better explanation, I think just now I realized it, that you have to just select 5 gaps, 5 other gaps out of remaining 8 and put 1, 1, 1. That's it. Okay, so 8C5, right? That's the better explanation. 8C5. Okay, so it's 9 into 8C5 is 8 into 7, I think, no? That's it. So you multiply 56 into 9, which is 504. So that should be the answer here, bachcho. So that's your fourth question. I think you all got it. Now see, fifth one, circle passing through the points of intersection of this. And now observe these two circles can't pass through the point. Can't pass through the point. So many of you might be thinking that this is a question of, or we need to use a family of circle concept to solve it. But see, in the latest syllabus, there's nothing called family. There's no tangent, equation, normal. They don't normally include it. They haven't included it in the syllabus, so we don't do it normally. Okay, but we'll be using the properties of the circle, one thing, and whatever geometry we can apply, whatever symmetry we can use. Okay, now look at these two circles. Aren't they are of same size? Of course they have same radius, which is √2, and their centers are the mirror images about the point 2, 1. So one is like 2, 1 and the one is like 1, 2. They are mirror images on the line y is equal to x. Yes or no? So that means these two circles are mirror images on this line. The only point we need to know is, does these circle intersect this line or not? So of course they intersect, because this line is y minus x equal to 0. So this distance is nothing but 1 by √2, if I am not wrong. Bachcho. So that means, and the radius is √2, which is greater than this distance. So the circle should be something like this, and the other one should be something like this. So they are mirror images. Okay, now Look at it. So any circle passing through, now of course one thing is for sure, any circle that passes through these 2 points of intersection can't pass through any line any point which lie on that line. And one point is clearly visible which doesn't lie on this line, and which lie on this line is 0, 0. So if there are 3 collinear points, you can't have any circle passing through those 3 collinear points. Hence, does can't pass through the point, and the point is 0, 0 here. Okay, so that was the logic behind this question. See, I will say that I just framed this question. Okay, I was thinking something, and then all of a sudden I just wrote this question. So that's the question which I framed. That's it. So next is this one. Of course, this is again a question which I framed just to see why did I frame this question. The point is, sometimes in the question you feel that it's a very difficult question, seeing the format of the question. Okay, integral, limit, summation, tan inverse. Okay, then it seems like it's a very difficult question, but the purpose of framing such type of question was to tell you all that if we just stick to the basic, sometimes the seemingly difficult question is really an easier one, or really a question which you would have done a similar question earlier. So I just, like they also do in JEE mains, I mean JEE paper, that they collect 2-3 standard things, mix them up and frame a good question, which seems to be a very difficult one. But when we move step by step, we realize, okay, these are the standard things. If we move step by step, we will be able to solve it. So let's start. So of course, the first part is R goes from 2 to n. Tan inverse. So whenever we come across this series, we know what to do. The point is, we just compare it with, so the formula is tan inverse A minus tan inverse B. Okay, so some of you may again say that we don't have any such result in the syllabus. Of course, I accept it, but then we should be ready for something, because in 2024 also they have asked the question which was not mentioned exclusively in the syllabus. Rather, they have deleted it. That's miscellaneous series. They have asked 1-2 questions from there also, and some other portions also they have asked the question. So let's be prepared for it, and most of you would have done it in your routine syllabus, routine classes for your JEE mains or JEE IIT examination, isn't that? So what do we know for it? So tan inverse A minus B upon 1 plus AB, that's it. So A and B. So the idea is to break C. That's a very important method to solve a series, and that is, the idea is to break the general term of the series as a difference of 2 terms. So I can write this as summation of tan inverse of r minus 1 upon 1 plus r into r minus 1. So I can write it as summation r goes from 2 to n tan inverse of r minus tan inverse of r minus 1. Bachcho, now just open this summation. So you start with like r is equal to 2. So the first term you get is tan inverse of 2 minus tan inverse of 1. Isn't that? And then for the, when you put r as 3, so tan inverse of 3 minus tan inverse of 2. Now the terms started getting cancelled like this one. So the rest of the terms will get cancelled, and as I always say, that if we are left with one negative term in the beginning when you are using this method, then you will be left with exactly same number of terms with opposite sign at the last. So one negative term in the beginning, so last will be the term which you will get, and you got it by putting r is equal to the initial value of r2. So the last term you will get when you put the final value of r, which is n, and you will get it from here, the positive part, tan inverse of n. So this is nothing but tan inverse of n minus tan inverse of 1, which is pi by 4. Okay, now limit n goes to t. So I mean, no big deal. So it's simply tan, limit has no role. It's just to convert it to a function, and then it's integral and dt. So what is it? So tan inverse t, integral is n to t. So tan inverse of t integral, I think we need to solve. Okay, so that's an integral also. So it's minus pi by 4t. Chaliye, that's done. So do we have any such part? Yeah. So q is minus pi by 4, at least we got it. And then see, the purpose here again was, might have been, when I would have framed this question, to again how to solve this thing. So you may go with integration by parts, or you may replace t by tan theta. So I will prefer to use here integration by parts. So 1 into tan inverse of t. dt. So it's like, of course this has to be the second function because we don't know integral of tan inverse c directly. So second function integral, so first function into integral of second function minus, and then we have what we have, minus t by 1 plus t square, okay, derivative of second function. So we got it. So it's t into tan inverse of t minus half times ln of 1 plus t square, and that's it, plus pi by 4, I think that was minus pi by 4 into t plus c. Let's compare it. So f of t, so f of 1 is, okay, so that's your f of t in that case if you compare it, okay, and then this is our p times, so p is minus half, so p is minus half, q is minus pi by 4, and f of 1 will be tan inverse of 1, so it's pi by 4, okay. So what do we need? We need the value of f of 1 plus 4p, which is v minus 2. So answer should be minus 2 because pi by 4 minus pi by 4 gets cancelled, so the answer should be minus 2. So that was a type of question which you may find. Such type of question, type means the form which seems to be so complex, but you move ahead step by step, ultimately you will be able to solve it, okay. You need to have patience and confidence that yes, we have already done such type of question. Now moving to the next question, in a binomial distribution, difference of mean and variance is 1, okay. Now let us first try to know or recall the formula. The formula for mean for binomial distribution is n into p. The formula for variance here is np into 1 minus p. Now what is n? N is number of times the experiment is repeated. Number of times experiment is repeated. And what is p here? P is probability of occurrence of any event, related event, occurrence of any related event, bachcho. Okay, so binomial distribution comes in the picture when there is no, like the probability of occurrence of an event doesn't change with the repetition of the experiment. So the experiment is repeated n times, and p is the probability of occurrence of any event. Like if I toss a coin 10 times, okay, now what is the probability of getting 4 exactly 5 times, okay. Now getting 4 as many times as you toss the coin, its probability is not going to change, it's fixed, which is 1 by 6. So that's how it works, okay. So you need to remember these two formula for binomial distribution and the terms which are involved here, and then the question is simple. Now they said that the difference of mean and the variance is 1. Now which one is larger? Of course this one is larger because 1 minus p is less than 1. So np minus np into 1 minus p is nothing but 1, and what else they have given? The difference of their square. So difference of their square will again give us one such thing, isn't that, into its sum np plus np into 1 minus p, and this is equal to 11. Okay, so here we get it as np common, and this is 2 minus p, which is 11, bachcho, isn't that, because this is 1. And here what do we get? So if I take np as common here, 1 minus 1, so it's np square, which is 1. Okay, now what will I do? I will just divide this by np square. So that's gone, that's gone. So just cross multiply, what do we have? It's 11p plus 12p, so p is 1 by 6. P is 1 by 6, okay. Now P is 1 by 6, just put the value anywhere, maybe NP square, okay. So NP square, n by 36 is equal to 1, so n is equal to 36, okay. So exactly 3 times. So what is the probability that it occurs, success, to get success exactly 3 times, okay. So actually it was 36, okay. I changed this to 6, okay. So I am really sorry for it. The paper you would have got there, in the options it will be 36 only. I got it corrected. I didn't look at it carefully. I just thought n is also 6, okay. That was my miscalculation. So it's like 36c3 nc3, exactly 3 times. So in how many ways? Out of 36 attempt of repetition of experiment, in how many ways you can have the success 3 times? You can have it in 36c 3 ways. You can have it in first 3 attempt. Any 3 attempts out of 36, you have to select 3 attempts out of 36. So 36 3 ways, and then number of times it happens is like 1 by 6 raised to the power 3, and number of times it does not happen is okay. That means answer is also wrong because it has to be 33 here. So in that case answer should be none of these. I'm sorry. So let's see. I think you would have got the answer correct, but see, okay. So there is typing error. I will accept there is typing error from both the ends. I myself committed error, and then there is typing error also. It has to be here. If that's the answer, it has to be 33 here. It has to be 36. Okay, I think all of you understood it. The importance of this question lie in this result, which I believe you all must be knowing. If not, then don't forget it now, bachon. Okay, so now let's move to the next question. So which question is it? Now we are at 8th question. Now that's an interesting one. That's a different one, and that's an interesting one. See, I will write it as 505 C5 minus 5 C1 into 404 C5 plus 10 is 5 C2. See, that's how I solved this question when I got it as a doubt, bachon. 5 C3, which is again same as 5 C2, which is 10. Into 202 C5 plus 5 C4, which is same as 5 C1, which is 5, into 101 C5, that's it. Okay, now see, whenever I get such type of question, and the subscripts in these cases, as we can see, doesn't change. So how do I start thinking? I start thinking as this expression as the coefficient of some fixed power of x in a binomial expansion. Okay, so I am repeating, I look at it as the coefficient of some fixed power of x in a binomial expansion. So now we have to think about that binomial expansion. Which binomial expansion may give us these terms or this series, but with a fixed coefficient of x. Okay, now how I started with like assuming it to be 1 plus x raised to the power 101. Now you may say that how can we think like that? See, the simple thing is, look at the superscript. The superscripts are the power, the multiple of 101. Okay, so 101 square will give you 202. Cube, 4 power, 5 power will give this superscript. So I started with 1 plus x raised to the power 101 minus 1 raised to the power 5. Now just expand it. So the first term is 1 plus x raised to the power 505. Minus 5c1 into 1 plus x raised to the power, this whole power 404. I think now all of you will agree and would have got what I am going to look for it in this series expansion, bachon. Okay, that's it. And then this is plus 5c4, 1 plus x raised to the power 101 minus 5c5. Okay, now as I said, normally how do I start thinking? I start thinking by looking at some constant power of x in the expansion. So if I look at coefficient of what, bachon? Coefficient of x raised to the power 5 here. So if you look at coefficient of x raised to the power 5, what we get here is 5 not 5 c5, and then this is so 5 not 5 c5 minus 5c1, that's a constant as product, and then in this expansion it will be 4 not 4 c5, and then see, this won't give you this a constant term, so that's why that was missing in the series. I think you got the series here, so that's the series which we need. Now what does that mean? That means in this expansion coefficient of x raised to power 5 is our answer. Now just expand this term. So when you expand it, so you get 1 plus 101 c1 x plus 101 c2 x squared dot and then minus 1 whole raised to the power 5. That's gone. That's gone. So x common, x is power 5, you get it, and this is 101 plus 101 c2 x plus dot whole raised to power 5. So in this expansion we already have x raised to power 5, the coefficient. So the coefficient will be this 101 raised to the power 5. I believe all of you will get it. Now see, you might be thinking, Chali, let me explain it quickly. 101c, we have to just multiply it 5 times, isn't that, bachon? That's a long expansion, dot. So multiply it 5 times, 101, so plus 101 c2 x plus dot and similarly 101 plus 101 c2x. So we have 5 such brackets. Okay, we need power of x raised power 5. We already have it outside. So what we need from this product? We need the constant term. And how will you get constant term? When you pick up this number from every bracket, from all 5 brackets, you need to pick up 101. So 101 into 101 into 101, 5 times. So the answer should be 101 raised to the power 5 here. So the answer is 101 raised to the power 5 here, bachcho. So A should be the answer here. A is the answer here. Now moving to the next question, which is based on sequence here, AP. So that's the question. I think that you all would have got it. So it's a simple question. Okay, so the question is, of course, it's an AP. So 2 times the middle term, 2 by 2 raised to the power x to the base 4 is equal to sum of the 5 into 2 raised to the power x plus 1 plus 1, and we can write 1 as log 2 to the base 2. Okay, now if I write it as 2 square, and we know the power of the base of log appears outside as reciprocal. So 2 by 2 log of 2 by 2 raised to the power x plus 1 to the base 2 is equal to, and log a plus log b, how much is it? Log a into b. So it is log of 2 into 5 times 2 raised to the power x plus 1 bachcho to the base 2. Now since log is a 1 function, we can remove the function and compare the input. So 2 by 2 raised to the power x plus 1 is equal to 10 times 2 raised to the power x plus 2. Now I will say let 2 raised to the power x be t, and see, we can easily see here that we are going to get a quadratic here. So which quadratic it is? So 2 by t plus 1 is equal to 10t plus 2. So it's 10t square plus 2t plus t minus 2 equal to 0. 20, right, we got it. So 10t square plus t, which is 5t minus 4t minus 2 equal to 0. 5t common, so t plus 1 minus 2 common, 2t plus 1, okay, that's 2t plus 1 equal to 0. Now see, t is equal to minus half is out of context here. Why? Because t is nothing but t is 2 raised to the power x, and we know exponential function can't be negative. It has to be positive. Okay, so that's one thing. And then so other possibilities, 2 by 5. So 2 raised to the power x is 2 by 5. Taking log to the base 2, both the sides, so what do we get? Log of 2 by 5 to the base 2. So that's x here, and then we can write it as log 2 to the base 2 minus log 5 to the base 2. So 1 minus log 5 to the base 2, 1 minus log 5 to the base 2. So that should be the answer. That was a simple question, isn't that? So that was question number 9 here. Moving to the next one. The sum of the series, again a simple question. But these type of questions you may definitely expect in the examination. So why is it simple? See, you need to look at the pattern. 1 plus, it's 3 plus 1 by 3. The difference between numerator and denominator, if that's a constant, you have that series, you will definitely get a GP. Most of the times it will be a GP, because, and then of course the denominator forms GP. Okay, you will get a GP. So that's it. So it's 9 plus 1 by 9, and then it's 27 plus 1 by 27 till n terms. So what is it? So it's 1 plus 1 plus 1. How many times, bacho? N times, isn't that? And what are you left with? 1 by 3 plus 1 by 3 square plus 1 by 3 cube. How many times? How many terms? N minus 1 terms. Okay, so it's n plus, so it's 1 minus 1 by 3 raised to the power n minus 1 by 1 minus 1 by 3. So which is 2 by 3, which is 3 by 2, isn't that? So it's we have 1 by 3 as the first term also. Okay, so now it's n plus 1 by 3, 1 by 3 get cancelled, half into 1 minus 1 by 3 raised to power n minus 1, and we have the answer directly, n plus half. So that's the direct answer. So that was a simple question, but the only purpose of sharing this question was this pattern. Okay, if denominator forms a GP and numerator and denominator's difference in every term is the same number, then you can always break it in this way. Okay, so that's the answer. So let's move to the next question, which is 11th one. F of x plus y is equal to fx plus fy plus 2xy minus 1. For all x, fx is differentiable, f dash 0 is sine phi. Then, now that's a good question, bachcho. That's a good question here. I will solve it because I solved it earlier with the help of two methods. First method is using partial differentiation. You may say that's not in the course, but see that this method might be quite useful. Okay, and might save your time using partial differentiation, and I will say differentiate both the side of this relation with respect to x, keeping y as a constant. Okay, so partial differentiation, treating y as a constant, differentiate with respect to x. What do we get? We get here f dash of x plus y is equal to f dash of x, and then keeping y as a constant, so this will go away, and here differentiating with respect to x, treating y as a constant is 2y. Okay, now put here x is equal to 0. So what do we get? F dash of y is equal to f dash of 0 plus 2y, which is 2y sine plus sine phi, because we are given the value of f dash 0 here. Now see, you got a simple direct differential equation which you can easily solve here. Okay, so this is nothing but f dash y. Okay, so if I integrate both the sides with respect to y, we get f of y is equal to sine phi times y plus y square plus c, isn't that? And then do we to get the value of c, so what shall we do is, let's put x is equal to y. See, that's the normal step which I always follow to get the value of f of 0 in such type of like functional relations. Okay, so we get f of 0 2 times f of 0 minus 1, so f of 0 is nothing but 1 here. Let's try it. So f of 0 is 1 here, so this is 1, this is 0 0, so c is 1 here. So c is 1. So therefore I can write that f of x or f of y is the same thing, isn't that? So y square, I changed it at one place, didn't change it at another place. So it's x square plus x sine phi plus 1. Now just find it, the minimum value. It's an open upward quadratic. Okay, minimum value will be at minus sine phi by 2. Do you agree, bachcho? So for an open upward quadratic, we get minimum value as minus b by 2a. At minus b by 2a. Put this value. So the minimum value of f of x is, put this value, so sine square phi by 2 minus sine square phi, sorry, it's 4 minus sine square phi by 2 plus 1. So how much is it? So it's 1 minus sine square phi by 4. Now see, if we see, we have to find the minimum value. So for that case, this has to be maximum. The maximum is 1 by 4 because the maximum value of sine square phi is 1. So 1 minus 1 by 4 is 3 by 4. That's the minimum value. So f of x is greater than or equal to 3 by 4, and that's it. Okay. So that's one way of doing it. Okay, now see, this is the condition, this is the statement which satisfies this condition, so I will say that's the answer here. But see, as I said, I will be using like solving it with the help of two methods. Another method is using the first principle of differentiation, which you all would have done. Okay, first principle of differentiation. Now what does it say? The statement here for first principle of differentiation is f dash of a is limit h tends to 0 f of a plus h minus f of a upon h. Okay, now use that relation, so we will get limit h tends to 0, x is a, y is h. So it's f of x, f of a plus f of y, which is f of h plus 2xy, and then minus 1 minus f of a by h. Okay, so here f of a is gone. Now, one interesting thing is we already know that f of 0 was 1, isn't that? We got f of 0 as 1 here. So this one can be replaced it. So let's solve it. So for this I will say limit h tends to 0 2a h by h. That's gone. Limit solved. It's a constant 2a plus. Limit h tends to 0 f of h minus f of 0 upon h. Now what is it? So this expression is nothing but f dash 0. Where is it gone? Wait for a minute. Yeah, this is nothing but bachcho f dash of 0. Just put the value a 0. Just put a equal to 0. You get this expression, and that is your sine phi. So this is plus sine phi, and you got the same relation, isn't that? F dash a. You got f dash y there as 2a 2y plus sine phi, and that's it. Okay, so those are two different ways of tackling such type of questions related to such type of functional relations. Okay, so that's your 11th question, and then we move to the next one. Next one is, if base of an isosceles triangle or base of isosceles triangles can lie anywhere on the line. So line on which the base lies fixed, and the vertex of all such triangle is a fixed point A1, and then the locus of centroid of all such triangle lie on. So what is it? See, if that's the line 2x minus 3y plus 4 or is equal to 4, whatever it is equal to 4, if the vertex is fixed A1 comma 1, and of course it doesn't lie on it, so that's the opposite vertex to the base. Now, infinite many combination of isosceles triangles are possible, isn't that, bachon? So that's why the question is for the locus of the centroid of all such triangle. But for an isosceles triangle, we know that if I draw perpendicular from the opposite vertex, which is the common vertex for the two equal sides of an isosceles triangle, to the base, then that is the altitude, of course, altitude of the triangle, but along with that it is the perpendicular bisector of the opposite side. It is also the median of the opposite side. So that means the centroid will lie on this line only and only. Okay, so and that's fixed because this line is fixed, and from this point the perpendicular line, you will always have a unique perpendicular line. Okay, and then that's the ratio 2:1. So this locus, so that's why the option none of these is also given. It won't be. See, normally where a student may commit mistake, they may commit mistake because of course that's a fixed line and a fixed point. See, that's a fixed line which may act as a directrix, that's a fixed point which may act as a focus, and then ratio. Okay, PF is to PM. PF is to PM is 2:1. So it may go like that, it's going to be a hyperbola, but no. It's a fixed point. Okay, so the answer should be none of these. I think you all would have got it. Yeah, none of these is the answer. Now moving to the 13th question. If the function f of x is ax cube plus bx square plus 11x minus 6 satisfy the Rolle's theorem. So if a function satisfy Rolle's theorem within the interval a to b, of course it has to be, the function has to be a continuous differentiable function in that interval, but along with that f of a should be equal to f of b. Now just solve it. So f of a is a plus b plus 11 minus 6 is equal to f of 3 will be 27a plus 9b plus 33 minus 6. So that gives us a relation. 26a plus 8b 22 equal to 0. So 13a plus 4b plus 11 equal to 0. Okay. Now see, one thing you all may try is just put these values, and whichever satisfy you get the answer. That's what you all, or most of you will do during examination, and that's what you all should do during examination. Okay, but then see, I'll be solving it with the help of the complete statement. I won't just go for hit and try type of thing. So f dash is 0. Okay, so f dash is 0. So if I go for f dash x, which is 3ax square plus 2bx plus 11 equal to 0, and this x is 2 plus 1 by root 3. So if I go for it and put the value here, so 3a times 2 plus 1 by root 3 whole square, 2b times 2 plus 1 by root 3, and 11 from here is nothing but minus 13a minus 4b equal to 0. Now see, 4b gone. So 2 by root 3b, so it's, that's it. Now for a, so 412 minus a. Okay, so it's minus a here for sure. And then we have plus 1 by 3, so plus a, that a is also gone. So the only a left here is 4 by root 3, so 4 root 3a. Plus this is equal to 0, so that gives us another relation, which is 2 root 3 6a plus b equal to 0. Now you can solve it, or see, now it's direct, even more direct. 1 comma minus 6 should be the answer. That satisfies it, isn't it? Now you can solve these two equations, okay, and then you get a and b. So that's it. So that's your question number 13. So moving to question number 14. So remaining part of this question you will find it in the next one. Okay, so that's otherwise that's going to be a very long video. So we'll be solving it in two parts. So that was the part 1. So remaining from 14 to 25 we'll do it in the next one, bachon.